Okay, so he's now put the data into a nice scatter graph. So he's recorded the time taken to read The Old Man and the Sea, measured in hours, and pair this with the percentage score in the final exam Y. So this is the time, this is the percentage in the exam. Part E, describe the coloration, the correlation. Now, there's only 1 mark going for this, guys. So, well, you could argue what does he want? What's the most important thing that he wants to know? And the answer is negative, that it's negative correlation. You could write strong negative correlation, that wouldn't be a problem, but the main word is negative. It's not that strong, but it's, if you put that into a calculator, I don't know exactly what you'd get, but it would probably be more than 0.9. So I would imagine, yeah, that's strong negative correlation. But anyway, the word he wants for that 1 mark is negative. Part F. He correctly calculates the equation of the regression line y on x for these students to be this. So this is the regression line. He has not asked you to calculate it. Fine, even though, well, yeah, that would be difficult to calculate using this graph, because you'd have to find every single point. He then uses this equation to estimate the percentage score in the final exam for a student who read the book in 1.5 hours. Find the percentage score calculated by Jason. So immediately I see a problem with that 1.5 hours, because it is outside the range of data, but I think that's part G. We'll get to that in a second. But note, guys, really, if this is your data, you should only be calculating percentages for people who've read it within this amount of time. Anyway, find the percentage score. So this is we're just going to sub in, we're going to sub in 1.5 here. Okay, let me just use my calculator. Negative 1.54. No, I don't want that. I want negative 1.54 times 1.5 plus 98.8, 96.49 equals 96.49. Always look, guys, does that make sense in context? Yeah, it's not a totally unreasonable thing to happen. So let's make it 96.5%. So, well, why might this be happening? So why would the people who've read it in a short amount of time be getting a better score? Well, who knows, but probably something to do with the people that are reading it quickly are really good at reading, because that's why they can read it quickly, because they're so good at reading, and hence they are good at understanding what they've read. But we've got a problem here, because this person took 1.5 hours. Now you could argue that they haven't read the book properly at all, because that's too quick. Who can read a big long book in 1.5 hours? So yeah, so I would guess this guy's not going to get like 96.5%. That's too good. But these questions, they're not testing what your opinion is on how fast it is to read a book. It's just checking your mathematical understanding. And what the problem with the 1.5 hours isn't that it's nothing to do with nobody can read a book in 1.5 hours. The problem is that it's outside the range of data that is collected. So let's write that down. Outside the range of collected data. That's what he wants to say. The 1.5, or maybe I should say 1.5 is outside the range of collected data. Or the real technical word is extrapolation. Extrapolation. That means you're using, remember what I said here, like this is your data, this would be your line from here to here, but you're using for 1.5 hours, that'll be here. So you're getting this data over here like this, and you're assuming. Because think about it. Imagine you said, okay, someone took 1 second to read a book. 1 second would be here. So does that mean they get 100% if they took 1 second? It doesn't make any sense. But this is the technical way to write it. It's outside the range of collected data or extrapolation.